Okay, so this is the 2026 Ordinary Level Leaving Cert Maths Paper 2. This is question 1. So let's see, we have the diagram below shows the line L, which is 2x plus 3y minus 18 equals 0. L cuts the y-axis at the point P, showed at the point P is 0, 6. If we look at the equation we're given, 2x plus 3y minus 18 is equal to 0. And we have to check if the point 0, 6 is on that line. So you should know that this is your x, this is y, so the 0 is the x, the 6 is the y. So really all you got to do is just sub those in and see, do you get 0? So it's 2 times 0 plus 3 times 6 minus 18 equal to 0. Let's see, do we? Well, 2 times 0 is 0, 3 times 6, 18, minus 18 equals 0. So we do get 0 is equal to 0, and that is it. So because we got the left-hand side equal to the right-hand side, the point is on the line. The line L cuts the x-axis at the point 9, 0. Find the area of the triangle in units squared, made between the x-axis, the y-axis, and the line L. So if we look back up here, the point P is 0, 6, and this point down here, they're telling us is 9, 0. So this is 9, 0. So in other words, the height of our triangle here is 6 units and the base of the triangle is 9 units. So we just got to find the area. The area of a triangle is half the base times the height. So it's going to be simply half 9 times 6. So the area of our triangle is equal to half the base times the height, which is a half of 9 times 6. So half of 6, 3 9s, 27, and it says our units are units squared. Okay, next one, find the slope of the line L, and the line L is 2x plus 3y minus 18 equals 0. So there are a couple of ways of measuring the slope or calculating the slope here. We have 2x plus 3y minus 18 equal to 0. So the easiest way is probably just to put it in the form y is equal to mx plus c. So we'd want to make it look like this. Y is equal to mx plus c. So let's try and get the y on its own. So let's see, we'll get rid of that 2x anyway by subtracting 2x from both sides. And then we'll get rid of that minus 18 by adding 18 to both sides. So that'll leave us with 3y is equal to minus 2x. We subtracted 2x from both sides. We're going to add 18 to both sides. Okay, now we have this 3 stuck to the y. That means it's multiplying. So we need to divide by 3. So we divide by 3. It'll leave us with y. Divide each term by 3. So minus 2 over 3x plus divide 18 by 3. You'll get 6. So now this is in the form y equals mx plus c. So the slope here is just this number here, minus 2/3. Now another way of doing this, you may again or may not have covered this, but this formula here is in the form ax plus by plus c equal to 0. So the way you can simply find the slope when it looks like that is do minus a over b. So don't worry if you haven't covered this. You've probably covered this way over here, so you can just use that method. Either method is fine. So what we're going to do here is look at a. Well, the a is the 2, so it's minus 2 over the b. Well, the b is plus 3, so over 3, and you get minus 2 over 3 as well. So this is our answer here. Minus 2 over 3. The slope is minus 2 over 3. The line K passes through the points A and B and is perpendicular to the line L. Work out the value of OR. Okay, so we have the slope of L. This is our line L there, which we just worked out as minus 2 over 3. So the slope of L is minus 2 over 3. A line K then is perpendicular to L, so that means the slope of K, all you've got to do is take the slope of L, turn it upside down and change the sign. So it's going to be 3 over 2. So the slope of K is 3 over 2. So now we know the slope of K. All we've got to do now is work it out using the information that we have. We have x1, y1, x2, y2. We know that the slope of k is also y2 minus y1 over x2 minus x1. So that's just 7 minus 2 over or minus 4. So 7 minus minus is plus, so 7 plus 2 is 9 over or minus 4. So in other words, 3 over 2 must be equal to 9 over or minus 4. When you've got a fraction equal to a fraction, all you've got to do is cross multiply. So we're going to multiply the 3 by the or minus 4. We're going to multiply the 2 by the 9, which is 18. So we just got to solve for or. So multiply out the bracket. 3 or minus 12 is equal to 18. Add 12 to both sides. 3 or is equal to 30. The 3 is stuck to the or, so it's multiplied. The opposite of multiplying is dividing, so divide by 3. So or is equal to 10. This is our answer here. That's all we had to do, work out the value of or. Okay, so next question. Question 2. 8 schools, A, B, C, D, F, G up to Z, are competing in a chess tournament. The schools are divided into 2 groups as shown in the table. At the beginning of the tournament, each school has an equal chance of winning its group. The winner of Group 1 will play the winner of Group 2 in the final. Complete the table below to show all possible pairings for the final. Some have already been done for you, for example. So I've done this already. I've just completed the table. So this one here would be A, Y. This one here would be A, Z, and so on. It's easy enough. Okay, write down the probability that school B plays in the final. So the probability that B plays in the final is equal to, well, there are 16 in total, 16 outcomes, so you put 16 down here. And then B in the final, well, you've got 4 B's, you've got these 4 here. So it's 4 out of 16, which is just 1 over 4. Okay, I see I've left out a Y. So anyway, next one is school D withdraws before the tournament begins. The groups remain the same but without school D. Each remaining school in group 1 still has an equal chance of winning that group. Work out the probability that B or school Z, but not both, now play in the final. Okay, so D has pulled out, so we need to get rid of all the D's. We want the probability that B or Z would not both play in the final. So both would be here, so we want to get rid of that one. So really all we've got left are these 3 here. This one has Z, this one has Z. So we've got 5 in total out of 12. There are now 12 in total here rather than 16. So it's 5 over 12 really. So the answer is just 5 over 12. Okay, next one, B. Let's see. Erica and Peter play against each other in a different chess tournament. The probability that Erica wins a game is 0.6, and this remains the same for each time that they play. There are no draws. Write down the probability that Peter wins a game. So the probability that Peter wins is just going to be 1 minus 0.6, or just 0.4. The first player who wins 2 games wins the match. For example, Erica could win the match by winning the first game, losing the second, and winning the third. Work out the probability that Erica wins the match. So the probability that Erica wins, well, let's have a look at the different ways she can win. She can lose the first one, she can win the second one, and win the third one. And means you're going to multiply here, by the way. Or means you add. She can win the first one, and means you multiply, lose the second one, and means you multiply, wins the third one. Or means you add. She could win the first one and win the second one. They don't play a third one here because she's already won. They stop at that stage. So these are the 3 possibilities, the only 3 possibilities where Erica can win the entire match. So let's put in those probabilities. Lose times win times win. So losing is 0.4. winning is 0.6, winning is 0.6. So that's the first one here. Or then means you add, winning is 0.6 and losing 0.4 and winning 0.6. Add again, so that was that one there. Now she's going to win both, so it's 0.6 times 0.6. So you just got to do all of those. When you do them individually and then add the three answers, you should get a probability of 81 over 125. Or you could say in decimal 0.648. Either one is fine. Okay, that's it for that question. Okay, question 3. Tara is going on a school trip. She must choose one activity from each of the following categories. So you have 3 categories there. Find how many different choices are possible if Tara chooses one activity from each of the following, or each of the 3 categories. Okay, so this is basically the fundamental principle of counting. So we have 1, 2, 3, 4, 5 options in category 1. We have 1, 2, 3, 4, 5, 6 options in category 2. And we have 1, 2, 3, 4 categories in option 3. So all you got to do is multiply those and you get 120. So 120 different options. So for example, they could pick zipline painting and pizza making, or they could pick rock climbing, drama, barbecue, and so on and so on. There's 120 different options there. Okay, so next question then. The organizers need to remove one activity from one of the categories. From which category should they remove an activity if they want to keep the greatest number of possible choices? Use calculations to support your answer. Okay, so we had 5 by 6 by 4 in question 1. So let's just remove one of these here. So that would leave us with 1, 2, 3, 4 times 6 times 4. So let's do that. 4 times 6 times 4. If you do that, you get 96 options. Well, let's say we put that one back in here and we take one out of the middle category. So that would leave us with 5 times 5 times 4. So let's see how many we have there. So it's 5 times 5 times 4. That'll leave us with 100 options. So that's a better one. Let's have a look at the next one. Let's say we have 5 here, we have 6 here, and let's take one of these out. So it's 5 times 6 times 3. 5 times 6 times 3 will give you 90. So the best option would be to take one out of category 2. That'll give us the most number of options. So it is category 2. So it's this one here will give us the most options. Okay, next one. Tara is sitting her 5th year summer exams. She will have exams in 7 subjects which can be arranged in any order on the timetable. In how many ways could the order of the 7 exams be arranged? Well, that's just simply 7 factorial, which is, you can do that on your calculator, it's just 5040. Or if you think about it, if you want to do, some people like to do this kind of a box method here. So you just do 1, 2, 3, 4, 5, 6, 7 boxes. We're going to multiply each of these. And if you look at the first one here, how many options do you have to go into that particular box there? Well, you'll have 7 exams, so there are 7 exams you can choose, so you have 7 options there. If you've chosen one of those exams, there are only 6 exams left to go into this box here, so you got 6 in there. If you've chosen those 2, there are only 5 left to go there. 4, 3, 2, 1. That'll give you 5040 as well. That's basically just 7 factorial. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. So this is our answer. Tara will have 3 exams on Monday. In how many arrangements? That word there is very important. You've covered, I think, this idea here in P-or. That's arrangements. So in how many arrangements of the 3 different exams can be made from the 7 exams? So really that's just 7p3. You can do that on your calculators and you'll get 210. If you want to use the box way of doing it, you just need 3 boxes, which again we're going to multiply. So in this particular case, how many possibilities are there for the first box, if you like? Well, there are 7 exams, so we could put 7 in there. Then once you've chosen one of those exams, there are 6 left to go here. Once you've chosen those 2 exams, there are only 5 left there. You'll also get 210. So that's our answer there, 210. Okay, let's have a look at the next one then. It is decided that maths will be the first subject examined on Monday. How many arrangements can now be made for the remaining exams on Monday? Okay, so we've already decided maths will be the first one. So we can forget about maths, so there are only 6 left. And we've got to arrange 2 more for the Monday because there are 3 on the Monday. So 6p2 on your calculators will give you 30. Or again, if you want to do this box method, you can just do 3 boxes for the Monday. You have only 1 choice for the first exam, so we're going to put 1 in there. You have, once you've picked maths, there are 6 left, so we've got to put 6 in there. And then once you've picked maths and 1 other subject, there are only 5 left. So 5 6 is 30, so this is our answer. And that's it for that question. Okay, next question, question 4. The diagram below shows an isosceles triangle with the base extended. Some measurements are given. Find the size of the angle marked A and the size of the angle marked B. Okay, so we can see here that this is an isosceles triangle. We've got 12 centimeters and 12 centimeters. That means this angle here and this angle here are the same. So this is actually A as well. So we can say that the 3 angles of a triangle add up to 180 degrees. So if we take 180 degrees, subtract 44, that'll give us the size of these 2 angles added. You've just taken 44 from 180, so that gives you the remaining 2 angles. Because they're the same, all we've got to do is divide by 2. So we can just take that, divide by 2, and that's our angle A. So A turns out to be 68 degrees. So this is 68 degrees. In order to work out B, all you've got to do is take 180 degrees and subtract 68 degrees, and that gives you 112 degrees. And that's equal to B. So B is equal to 112 degrees. Because this is a straight line here, it's 180 degrees. The other way of doing that is to use a theorem. You know from one of your theorems that the exterior, if you have a triangle and you have an exterior angle, that's equal to these 2 angles here added, the 2 interior opposite angles added. So in other words, B is just equal to 44 plus 68. That'll also give you 112. But anyway, that's that question. So A is 68 degrees and B is 112 degrees. Find the area of the triangle, give your answer correct to the nearest whole number. So in this triangle here, we have 2 sides, 12, and we have an enclosed angle. We have the angle enclosed by these 2 sides, so that should immediately tell you that you need to use the area formula, which is half AB sine C. So it's half of 12 times sine 44. So the area of our triangle is equal to half of 12 times sine 44 degrees. All of that you can just stick into your calculator, and what you should get is 50.015, and we have to give this the nearest whole number, which is 50. It's an area, it's in centimeters, so it's centimeters squared. Okay, next question then. A triangle PQR has those measurements there. Use the cosine rule to work out the size of the angle QPR. Give your answer to the nearest degree. It may be useful to draw a diagram. Okay, so let's draw a diagram. So we have a triangle. The triangle is PQ and R, so let's do PQ and R. PR is 12, so that's 12 centimeters. PQ is 9 centimeters, so that's 9 centimeters. And QR is 10 centimeters. Work out the angle QPR. So QPR is here. I'll mark it alpha. So the cosine rule says that if we want this angle here, for example, what we've got to do is start with the side opposite. So we've got to start with 10. So we're going to take 10, we're going to square it, And then we're just dealing with the other two sides and the angle enclosed by those two sides. So it's going to be 9 squared plus 12 squared minus twice 9 times 12. And then it's the cosine of the angle in between. I'm saying it's alpha. Okay, so let's just work through this then. 10 tens, 100. 9 nines, 81. 12 twelves, 144. And then minus 9 times 12 times 2, which is 216 cosine alpha. So I'm going to subtract, I'm going to get rid of these two here, the 81 and the 144. Bring those over to the other side, or subtract them from the right hand side and the left hand side. You'll get minus 125 on the left hand side. You get minus 216 cos alpha on the right hand side. So what we're going to do now is that minus 216 is multiplied by the cos alpha, so divide by minus 216. So it's really minus 125 divided by minus 216 is equal to cos of our alpha. So minus divided by minus is plus, so really this is just plus over plus, if you like, or just 125 over 216. To work out what alpha is, what you would do is get cos inverse 125 over 216. So that's something you can do on your calculator. You just press shift and cosine, or it depends on what type of calculator you have, but you do cos inverse 125 over 216. What you should get is 54.64058 and so on. We have to give this to the nearest degree. So to the nearest degree, that would be 54, but the number after the 4 is a 6, so we have to round that up to 55 degrees. That's our alpha. Okay, the next question is question 5. 7 friends at a match guessed in which minute the first goal would be scored. The guesses were 8, 11, 15, 17, 20, 20 and 23. Write down the mode of the 7 numbers and the range. So the mode is the number or the data point that occurs most often. In this case it is 20, it occurs twice. Find the range. Well, the range is the maximum, 23 minus 8. They have them in order for us from lowest to highest. So the maximum is 23, the minimum is 8. When you do that, you get 15, so the range is 15. And these are minutes, so the mode is 20 minutes, range 15 minutes. Write down the median. Now if you count these, there are 7 numbers, so the middle number is going to be 17. So we have 8, 11, 15. We've got 17 in the middle. We have 20, 20 and 23. So you can see if we pick 17 there are 3 on the left hand side, there are 3 on the right hand side. So that gives us a median of 17 minutes. So if there are an odd number of numbers, you do have an individual median. It's going to be the middle number. Sean joined these 7 friends just before the match started and also guessed in which minute the first goal would be scored. The new median, including Sean's guess, is now 16. Which of the following must be true about Sean's guess? Justify your answer. It may be helpful to try some values for Sean's guesses. So again, if we just write down these numbers, you have, let's see, 8, 11, 15, 17, 20, 20 and 23. So there are 7 numbers here. So now there is an extra number. There's going to be Sean's guess. So Sean's guess changes the median to 16. Now if you look at these 2 numbers here, the middle number between 15 and 17 is 16. So in other words, if you add 15 and 17, divide by 2, you'll get 16. So it would be really handy here if we had a number to the left of this number here, because we have 3 here. We want 3 numbers down here. So what could that extra number be? It can't go to the right hand side of this, because if we put in an extra number up at this end, anywhere along here, it means that this bracket here is going to shift to the right. We really want the median to be 16. So what we're going to do is look at some numbers here. Let's say we tried 16. So let's say we tried 8, 11, 15, 16, 17, 20, 20, 23. There are 8 numbers. There's an even number of numbers now, which means there are 2 middle numbers. So in this case, the 2 middle numbers are 16 and 17. So the middle number between these two is 16 and a half, 16.5. So that's not going to work. So what we need to do then is try 15. So let's try 8, 11. We already have a 15. Let's try another 15, 17, 20, 20, and 23. So here we have 2 middle numbers because we have an even number of numbers. And the median here is 16. So the median here is 16 minutes. So because we have 3 on the right hand side and we have 3 on the left hand side of those 2 middle numbers. So 15, if we put in 15, that works. So equal to 16 doesn't work. Less than or equal to 15 could work. More than or equal to 17 is not going to work. So what if we put in a number less than 15? So let me just, I'm going to have to go outside the box here. Don't do this in the exam. So you have, let's say we'll try 14 for example. 8, 11, 14, 15, 17, 20, 20, and 23. So again, we still have 2 middle numbers here. We've got 3 numbers on the right. We've got 3 numbers on the left. The median is still 16. So we need the number to be 15 or less. So it's going to be this one here. Now once you've done some of this stuff here in the exam, it's your justification really. You're trying some numbers and you have the correct answer up here as well. And as I say, don't go outside the box here. Okay, let's try the next one then. A board game has a spinner. A player either wins or loses points depending on which sector the spinner lands on. The size of some of the angles of the sectors and the number of points won or lost for each sector are shown in the diagram below. In one sector, a player wins X points. So that's here, 60 degrees. Work out the value of X so that the spinner is fair. That is so that the expected value of the number of points won is equal to 0. So this is an expected value type problem. And really that's just the sum of, this symbol here just means add up all your X values multiplied by the probability of X. Don't worry if you don't quite understand that. I'll run through that in this particular case. So what we need to do here is we're told that the expected value is 0. So that means we're going to put 0 on the left hand side and then we're going to work out each probability and multiply it by what we're going to win or lose. So if we look at this here, for example, the probability that the spinner lands in this particular area is 1/3 because 120 degrees is 1/3 of 360 degrees. So there's 1/3 of a chance that you're going to land here. And if you land here, you're going to win 19 points. So let's write that in. So you can win 19 points and the probability is 1/3 of winning that. So that's one of the sectors. And then you add, this is the sum part here. This is the 19 times 1/3. So let's look at another section. We have lose 20 points. Lose 20 points, so we're going to be subtracting. The probability that the spinner lands in this area is half. It's half the circle. And we can lose 20 points. So it's going to be plus, let's see, we're going to lose 20 points. And the probability is a half. Okay, now let's look at this area here with the X in it. There are 6 60 degrees in the entire circle. So the probability of landing here is 1/6. What can we win? We can win X number of points. So it's going to be X times 1/6. So this is our equation here. We've just got to simplify that and try and isolate the X. So let's see if we can do this. So we got 0 is equal to 19 times 1/3. Well, let's just do 19 over 3. Plus times minus minus. Half of 20 is 10. And over here we end up with 1/6 X. 1/6 X. So it's plus 1/6 x. Okay, so what I'm going to do now is, you can see we've got a 3 on the bottom, we've got a 1 on the bottom, we've got a 6 on the bottom. So I'm going to multiply each term by 6. So multiply 0 by 6, you'll get 0. Multiply 19 over 3 by 6. Well, the 6 will be on the top, so it's 19 over 3. We want to multiply that by 6 over 1. So the 3 will divide into the 6 twice. And then we just end up with 1s on the bottom and 2 19s. So that is 38 minus, let's multiply the 10 by 6, that'll give us 60, and then multiply the 1/6 by 6. Well, 1/6 multiplied by 6 over 1, if you like, that'll divide into that. We just end up with 1s, so it's just 1 times x, which is x. So we end up with, let's see, 0 is equal to 38 minus 60. So you go up 38, you go down 60. You end up with minus 22 plus x. Add 22 to both sides. You get 22 is equal to x. So x is equal to 22, and they are points. So x is equal to 22 points. That's it for that question. So next question, the rectangle EFGH is an enlargement of the rectangle ABCD as shown in the diagram below. The points A and B lie on E and F. So this is EFGH. This is an enlargement of this smaller rectangle here. And these 2 points lie on EF. Measure the length of AB and the length of EF in centimeters. So we've got to measure this length from A to B and the length from E to F. Now I can't do this. I don't have the original paper, so I just measured it on screen. And I'm getting 4 centimeters here and 10 centimeters here. You guys will get different measurements, I suspect. But anyway, use your answers to A1 to work out the scale factor. So the scale factor is called K. All you've got to do is take the 10, divide by 4, and that gives you 2.5. So this is the scale factor. It just means that this distance here will be 2.5 times this distance here. Construct the center of enlargement on the diagram above and label it K. Okay, so I can't draw straight lines here, but basically what you do is you're going to take an image point, draw a line down through the object point, continue it on, and you'll end up there somewhere. Do the same to another one. So take G, go down through C, not very straight, but it should intersect here. This is going to be your center of enlargement. Let's call it O. You can also take E, go through A, and that will obviously go through it as well, and take F, go through B, and that will go through it as well. So there's your center of enlargement. What do they call it? Construct a center of enlargement. Label it K. So I've got to label this K, not O. So that's it for that there. Obviously use a ruler. The point O is the center of the circle U. So there's the center of the circle U, and also the center of the circle T. The points P and Q, so these 2 points here, are on the circle U, and the points S and R, these 2 here, are on the circle T. S is an element of OP, so S is on this line here, and R is on this line here. This angle here is 120 degrees. Explain why OP, so OP, the distance from here to here, and the distance from O to Q are the same. Well, they're both radiuses of this circle U. So you just write that in, and that's it. Show that the triangle OPQ, so OPQ, this big triangle, and OSR, this little triangle here, are similar. Give a reason for each statement that you make where relevant. So if we draw the 2 triangles, the first one is OPQ. This is 120 degrees in here. This side is going to be equal to this side here because they're radii, both radiuses of the circle. If we take the smaller triangle then, again we've got O here, we've got S and R here, S and R, S and R here. So this side here is going to be equal to this side here as well. So we can say something like OP is equal to OQ, and the reason for that is that they're both radii of the circle U. Therefore, triangle OPQ is isosceles. Therefore, the angle OPQ is equal to the angle OQP, which is 30 degrees. So it's similar, it's the same for this triangle here. So OS is equal to OR because they're both radii. Therefore, triangle OSOR is isosceles. Therefore, the angle OSOR is equal to the angle ORS is equal to 30 degrees. And therefore, at the end, triangles OPQ and triangle OSOR are similar. So that's kind of a long-winded explanation there, but that's the reasoning. All I'm saying really there is that that's a radius of U, so therefore this angle and this angle must be 30 degrees if that's 120. Same here, that's a radius of this circle T, so therefore this is also 120 degrees here, this is 120, so therefore this angle here must be 30, this angle here must be 30, so you've got 120, 30, 30, you've got 120, 30, 30, so they're both similar. So that's really it for that question. Okay, the first of the long questions then. In a computer game, there are a number of overhead lights that each create a circle on the ground. These circles are positioned using a coordinate diagram. One of the circles C has equation x squared plus y squared is equal to 72. Write down the center and the radius of this circle C. Give the radius in third form. So when you see an equation like this, x squared plus y squared is equal to r squared. It's in this format here. X squared plus y squared is equal to r squared. That means the center is 0, 0. The radius then is just going to be the square root of 72. Now the square root of 72 is just 6 root 2. If you type that into your calculator, press equals, you'll get 6 root 2. In the game, the player must move their characters so they avoid the circles of light. Tony's character is at the point -4, 9. Investigate if the point -4, 9 is inside, outside, or on the circle. Use calculations to support your answer. So we have the equation x squared plus y squared is equal to 72. A couple of ways of doing this. What you can do is put the x, remember the -4 is the x and the y is the 9. So what you can do is put -4 in for the x, square it, put y in as 9. What you'll get is 16 plus, that's squared here, 9 9's 81. That'll give you 97. Now since 97 is bigger than 72, the point lies outside C. Therefore, -4, 9 lies outside C. The other thing you can do, if you imagine you have a circle, you have a radius of the circle. We know the radius here is 6 root 2, and we know from what I've just done that it lies outside. So if you can find the distance between the center and the point -4, 9, if that's bigger than the radius, then it has to lie outside, the circle. So the distance formula is the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. So our 2 points are 0, 0, the center of the circle, and -4, 9. So I can call this, let's say, x1, y1, x2, y2. The distance then from 0, 0 to the point that we're looking at is the square root of -4 minus 0 to be squared, that's x2 minus x1, 9 minus 0 to be squared, that's y2 minus y1. So that's just the square root of -4 times -4 is plus 16. That should be plus 9 times 9, 81. So here we're going to get the square root of 81, 91, 97. So the square root of 97, if we were to change that into a decimal, is 9.85 to 2 decimal places. The radius then of our circle is 6 root 2. And if you were to change that into a decimal, you'll get about 8.49 to 2 decimal places. So 9.85 is bigger than 8.49, therefore it lies outside of C. So two different ways of doing the same thing. Okay, next one. First, Tony moves his character from point A to point B. Find the equation of the line containing the points A and B. Give your answer in form ax plus by plus c equals 0. So this is just a matter of finding the equation of a line given 2 points. So we're given minus 4, 9 as A, and we're given 0, 12 as B. So what you would need to do here, first of all, is you're going to use this equation here, y minus y1 is equal to m into x minus x1. Now in order to use that formula, you need two things. You need a point and a slope. We have 2 points, so we can choose either of those. We don't have the slope, so we're going to have to work out the slope. The slope is y2 minus y1 over x2 minus x1. So let's just mark these x1, y1, x2, y2. So it is 12 minus 9 over 0 minus 4. So 12 minus 9 is 3, and on the bottom you've got minus minus, which is plus. So the slope is 3/4. Let's just stick in some values here. Probably the best one to do here, you can use either point. I mean, you can use minus 4, 9, or you can use 0, 12. You'll get exactly the same answer. I like to use points with zeros in them. That usually makes things easier. So y minus, I'm going to say 12, is equal to 3 over 4 times x minus 0. So what you do here then is you take the 4 on the bottom of that fraction there, and you're going to multiply both sides by 4. So you would write down 4 bracket y minus 12 is equal to 3 bracket x. So multiply it out. You've got 4y minus 4 12s 48 is equal to 3x. We need everything over to one side. We need it in the form ax plus by plus c equal to 0. So bring everything over to the right hand side. And then I'm just going to flip everything around. Just going to put the x first, 3x. I'm going to bring the 4y over. So it's going to be minus 4y. I'm going to bring the minus 48 over. I'm going to add 48 to both sides. So that will just be plus 48, and then that's equal to 0. So this here is my answer. Okay, next one then. Next, Tony moves his character along the line L. He does not want the character to enter the circle C. So they give you the line L and they give you the circle C. Use simultaneous equations, or otherwise show that the line L is a tangent to the circle C. So using simultaneous equations is the best thing to do here. So we have our two equations here. We have x plus y is equal to 12, and we have x squared plus y squared is equal to 72. Normally what you would do is you would take the linear equation, the one without any squares or cubes or whatever in it, and rearrange it, get x on its own or get y on its own. I'm just going to get x on its own here, so I'm going to say x is equal to 12 minus y. I just subtracted y from both sides. Now if x is equal to 12 minus y, I can put x in here in the second equation. I can put 12 minus y into the second equation, so I've just put it in here. Plus y squared is equal to 72. I have an equation now with just y in it, so I should be able to just work out what y is. So I've got to square this out first. So the way you would do that is you would say it's just 12 minus y times 12 minus y. What you'll get when you do it is 144 minus 24y plus y squared. You can try that yourselves. Just write out 12 minus y in a bracket and then 12 minus y in another bracket. Multiply it out, simplify it. You should get this here. We've got another y squared. It's equal to 72. Simplifying that, we get 2y squared. We've got a minus 24y. And then we've got a plus 144. We've got to subtract 72 from the right hand side. So subtract 72 from the left hand side, and you should get 72. So plus 72. Okay, now I can see here I've just got a simple quadratic trinomial that I've got to solve. You can use the quadratic formula, the minus b formula if you like, or you can just try factorizing it. I'm going to factorize it. So I can see here that I've got an equation first of all, but I can see that each term is divisible by 2. So I can make this simpler by dividing each term by 2. So I'll get y squared there, I'll get 12 here, and I'll get 36 here. So that just makes it a little bit easier to factorize. So when you factorize it, what you'll find is you'll get y times y. 36 has a lot of factors, but the ones that work will be 6 times 6. 6 sixes are 36. I need a plus 36, so the two signs have to be the same. Because I've got a minus 12y, it's going to be minus minus. So that does work. So that just means that y minus 6 is equal to 0, or y minus 6 is equal to 0. So in other words, y must be equal to 6 when you add 6 to both sides. So really you're just getting one solution here. Y is equal to 6. Pick one of the equations. I'm going to pick x plus y is equal to 12. That's the first equation here. And I'm just going to put in that 6 instead of x. And what happens is I get y is equal to, subtract 6 from both sides, and you get y is equal to 6. So the point of intersection is x is equal to 6, y is equal to 6. So you would say something like, as there is only one point of intersection, the line L must be a tangent to C. So that's it. That's the entire part of that question finished. Let's have a look at the next part. Another light creates the circle S with center 5 minus 10 and radius 10. Construct the circle S on the coordinate diagram on the right. Now I have done this already. I can't do it accurately. I have to do it by hand, so it's very shaky. You guys would need to use a compass. So it says the center is 5 minus 10. So 5 minus 10 is here. The radius is 10, so you've got to go out 10. So 5, 10. This is 10 out as far as here. 5, 10, it's 10 up as far as here, 10 out as far as here, 10 as far as here, 10 as far as here, and so on. So the radius of this circle is 10. You guys would need to do this a lot more accurately than I've done it here. Write down the equation of circle S. So the equation of a circle whose center is not 0, 0 is x minus h to be squared plus y minus k to be squared is equal to r squared. So h and k is the center of the circle. So our center is 5 minus 10. So this is h and this is k here. So it's going to be x minus 5 to be squared plus y minus minus 10, so that's plus 10 to be squared, is equal to the radius squared. So the radius we're told here is 10. So square 10, you get 100. That's the equation of our circle S. Okay, next part then. Two more lights create the circles T and U. So we have T and U here, each with radius 10 centimeters. So you're going from 35 to 25, you're going from 25 to 15. Here you're going from 0 to 10 on the y-axis. So there is a bit of a gap between these two here. T and U are shown on the coordinate diagram on the right. Tony wants to move his character along a horizontal line between the circles T and U. So along here somewhere. He wants to move horizontally along here. Write down the equation of one such horizontal line. Okay, so horizontal lines will have the equation y is equal to something, because if you imagine an x and y axis, if that's, let's say, 3 there, if you draw a horizontal line along there, all the points on that line will have a y value of 3. So you'll have 1, 3. So that might be 1. So that would be 1, 3. This is 2, 3. This is 3, 3, 4, 3. This would be minus 1, 3, and so on. So y is equal to 3 would be the equation of this line here. Now in our case, we want to draw a line along here somewhere so that it doesn't touch either of these circles. Well, we know that there is a gap between 10 and 15. So you can write the equation as y is equal to 11, y is equal to 12, y is equal to 13, y is equal to 14. Any of those will be fine. So if you say y is equal to 13, that would be correct. And that's really it for question 7. Okay, this is question 8. Contestants on a reality show are based on an island. They are divided into Team A and Team B. The diagram below shows the camp for each team. Both camps are in the shape of right angle triangles. Some measurements are shown. So here we have Team A, here we have Team B. 60 meters, 25 meters, 45 meters here. A fence runs along the side SQ, so along here, to separate the two camps. Use Pythagoras' theorem to show that SQ is 65. Okay, so I'm going to use this triangle down here. We've got one side here, 25 meters. We've got another side here, 60 meters. We don't have the hypotenuse, so I'm just going to do Pythagoras' theorem. So Pythagoras' theorem states that the square on the hypotenuse is equal to the sum of the squares on the other two sides. So the other two sides I'll do first. 25 squared plus 60 squared should be equal to the distance from S to Q squared. Okay, so when you square 25, square 60, add them, you should get 4225. That is SQ squared. So what you got to do now is square root both sides. So that means the distance from S to Q is the square root of 4225, which is 65 meters. Now when you get the square root in an equation like this, it's actually plus or minus, but you can't have a negative distance, so it's going to be the plus 65 meters. Find the size of the angle marked theta in the diagram, that is find SQR. Give your answer correct to 1 decimal place. So what we're going to do now is look at this here. So we've already found that this is 65 meters. It's a good idea to fill in these diagrams as you go along, just in case you forget that you've actually done something. But anyway, we need to find this angle down here. So I'm just going to redraw this triangle. We just have to rotate it a little bit and redraw it. So we have, let's see, we have our angle theta. I'm going to put down here. The angle is at Q. So you can see here theta is at Q. The right angle is at OR. So I'm going to put OR over here. And then the other one is S. So we're going to put S here. Let's put in the measurements then. Well, we know that SQ is 65. We've just done that. So that's the hypotenuse, 65 meters. We also know that SR is 45 meters. So this is 45 meters here. So we've got to work out the angle SQR. We've got to work out theta. So we have the opposite. We have the hypotenuse. So we're going to look at sine of theta is equal to 45 over 65. So the way you find theta then is just to find the sine inverse 45 over 65. Again, just make sure your calculator is in degrees mode. So we've got theta then equal to 43.81306 and so on. We've got to give theta to 1 decimal place, so it's just 43.8 and it is degrees. Okay, next one. The team must complete tasks. One task is to approximate the area of the island. A contestant uses a map and measures the width of the island at 0.5 kilometer intervals. These widths are given in the diagram below. Use the trapezoidal rule to estimate the area of the island. So the area then from the trapezoidal rule, there's kind of a formal one in your tables, but it's basically h over 2. The h is the all the 0.5s. So then it's, I'm just going to write down my version. It's going to be the first one plus the last one plus twice the sum, or you just add up all the rest. And that's basically the kind of informal equation, if you like. So I'll just explain what I mean by each of those. The h is 0.5 over 2. The first one is the first kind of height here, if you like. You can see that you've got a height here of 1.2 kilometers, but that's not the first height. So if you start here, for example, you're leaving out this part of the island. If you finish here, if you use 0.8 as your last height, then you're leaving out this part of the island. So you've got to start here. So what's the height here? Well, it comes down to a point here, if you like, so it's just 0. And same with the last one, you're coming up to a point here, so it's just 0 heights there. So I'm going to say 0 plus 0, and then it's plus twice all the others added. So now I'm including the 1.2 plus the 1.5 plus the 1.3 plus the 0.9 plus the 0.8, and that is it. So you've got to just work all that out. So 2 into 0.5 is 0.25. We've got to just work out this here then. When you do that, you add all those up, multiply by 2, and you get 57 over 5. So when you multiply all that out, you get exactly 2.85, and this is an area, it's an approximated area, so it's kilometers squared. Okay, part C then. Another task is to row a boat from the point W to the point X, so that's from here to here, and then to the point Y. As shown in the diagram below, these particular dimensions are already in here. We've got 42, 122 meters and 65 degrees. So, and this is 90 degrees here. Work out the distance from X to Y, so this distance along here. Okay, so what we got here is a non-right angle triangle, so we can't use Pythagoras' theorem or sine cos tan directly anyway. So what we're going to do is use the sine rule. So we're going to say sine of 65 over this here is equal to sine of this angle over this side here. We've got to find xy. Now the problem is we don't know this angle here. We've got to work this one out. So what we're going to do first is we're just going to work out what size this angle here is. So in order to do that, we need this angle here. Now we have a straight line here. We know this is 90 degrees. We know this is 42. So to work out this angle, I'm going to subtract 42 and 90 from 180. That'll give me this angle here. So I'm going to write that down. So 180 degrees minus 42 degrees minus 90 degrees. When you do that, you get 48 degrees. So that's this angle here, 48 degrees. Now in order to work out the angle at W, we need to take 180 degrees, we need to subtract 65 degrees, we need to subtract 48 degrees, because the three angles add up to 180 in a triangle, and we find we get 67 degrees. So this angle here is 67 degrees. So I can now start the sine rule. So what I'm going to do is say the sine of 67 degrees divided by the opposite side, the length of the opposite side, which is xy, is equal to the sine of 65 degrees divided by the length of the opposite side, which is 122 meters. So now we have a fraction equal to a fraction. We can cross multiply. So we have 122 times the sine of 67 degrees is equal to the length xy multiplied by sine 65 degrees. So now I need the length xy on its own. It's multiplied by sine 65, so I'm going to divide the left hand side by sine 65. So it's 122 sine 67, all divided by sine 65 degrees. So that gives us the length xy, which is what we're looking for, and that's going to be equal to 123.911097. We need it to the nearest meter, so xy, our answer then, is just 124 meters. Final task involves contestants building a fence around a piece of land. The piece of land is in the shape of a sector with an angle of 225 degrees and a radius of 50 meters, as shown in the diagram on the right. So 225 here and 50 meters here. The team must build a fence all around the perimeter of the sector, work out the total length of the perimeter of the sector. So we know that this is 50, this is going to be 50. What we've really got to work out is this length around here, and then just add that to 100 if you like. So let's do that. So the distance, the total length, is equal to 50 plus 50, which is 100 meters, plus, now the circumference of an entire circle is 2 times pi times r. So I'm going to write that down first. it's 2 times pi times the radius of the circle, in this case is 50. You can imagine if that was a complete circle there, the radius would be 50. So what we're going to do is we're just going to take 2 times pi times r, but we don't have a full circle, we have a fraction of a circle. So the fraction of the circle that we have is 225 over 360 degrees. So you can do all of that on your calculator and you should get 296.3495 and so on. We want this correct to the nearest meter, so that's 296 meters. Okay, next one then. The following year, the area of the sector is doubled. This is done by increasing the radius. The angle of the sector remains at 225 degrees. Work out the length of the new radius of this sector. Give your answer correct to 1 decimal place. So we still have this diagram here. However, the area is going to be doubled. So we've got to work out what the new radius is. It's not going to be 50 anymore. It's going to be some new radius. So the first thing I'm going to do is find the area of this sector with a radius of 50, and then I'm going to double it. So let's do that. So the area of a sector is going to be the area of the entire circle, which is pi r squared, but we don't have an entire circle, we have a fraction of the entire circle, so that's just the angle over 360 degrees. So in our case it's going to be pi times 50 squared times the angle is 225 over 360 degrees. When you do that, you get 3125 over 2 times pi. That's the area, and that's in meters squared. Now we've got to double this. The new area is double this area. So if you double this, if you multiply this by 2, the 2 will cancel. You'll just end up with the new area as 3125 pi. And then on the right hand side, we've got pi times the new radius, which we don't know, times the angle over 360. This is the area of the entire circle. We just want the area of the sector. So what we're going to do here is multiply by the angle, which hasn't changed, it's still 225. We're going to put that over 360 degrees. So this kind of works out nice and neatly. You've got a pi on the left hand side, which is multiplied. You've got a pi on the right hand side, which is multiplied. So we can just divide both sides by pi. The next thing I'm going to do is divide the left and right hand side by 225 over 360. Or what you can do is multiply by 360 and divide by 225. But what you should end up with is r squared is equal to 5,000. Works out exactly. Or then is just the square root of 5,000. Again, you take the positive version of it. There's no such thing as a negative distance. So it's 50 root 2. And that's in meters. So that's the new radius. And we have to give this to 1 decimal place. So my answer then, the answer is the radius is equal to 70.7 meters. Okay, and that's it for question 8. Okay, question 9 then. Noreen went to a musical festival. Noreen counted the number of songs each of 10 bands played during their particular set. The results are shown in the table below. Work out the mean and standard deviation of the 10 numbers in the table above. Give your answer correct to 1 decimal place. So I've done this already. The mean, you just add up all the numbers, divide by 10. You get 10.2 songs. The standard deviation, there is a manual way of doing it, but the best way to do this is just to type it into your calculator. You should really know how to do that. It varies from calculator to calculator, but whatever calculator you have, you should know how to do that. It'll actually do the mean as well, and a few other things, but in this case, you can type these numbers into your calculator, look up the mean, look up the standard deviation, and you'll get these two numbers here. One band played 5 songs. We can see that up here. This band here only played 5 songs. Is this an outlier for the data in the table above? Refer to a measure of variability to explain your choice. Okay, so it is an outlier. You can see it anyway because most of the data are between 9 and 13 and 5 is very low. So what I said here is that anything outside 2 standard deviations, generally speaking, is considered unusual. So if you take the mean and take 2 standard deviations below, 2 standard deviations above the mean, anything outside those will be considered unusual. So we know the standard deviation is 2.1. So if we take the mean, add 2.1, add another 2.1, we'll get 14.4. If we take the mean, 10.2, subtract 2.1, subtract another 2.1, we'll get 6. So anything within these two values would be considered fairly normal, and anything outside these two values would be considered unusual. So we have between 6 songs and 14.4 songs. This person or this group sang or played 5 songs. So that is below 6, so it is considered unusual. So this would be my explanation here. Also, by the empirical rule, you should know that 95% of data lie between plus or minus 2 standard deviations of the mean. So only 5% would be outside that. So that could be another explanation. The number of hours people at the festival spent watching bands were roughly normally distributed. The mean was 17 hours. The middle 95% of people spent between 14.2 and H hours watching bands. Using the empirical rule, find the standard deviation and find the value of H. Okay, so if we look at our normal distribution, it's going to look something like this. You'll have the mean in the middle, so that's going to be 17 hours in the middle. So we'll have 1 standard deviation below, 2 standard deviations below, 3 standard deviations below, 1 above, 2 above, and 3 standard deviations above. Now 95% of people spent between 14.2 and H hours. So 95%, you should understand by the empirical rule, is going to be all the data between minus 2 standard deviations, so here in other words, and plus 2 standard deviations above the mean. So that's the area that we're looking at in the graph. So if I just draw that in there, this is 2 standard deviations below the mean. This is 2 standard deviations above the mean. So 95% of the data is going to be in here. So they're telling us that the middle 95% of people spent between 14.2. So that number there must be 14.2. This number must be H. So what we've got to do is find the standard deviation and the value for H. So what we can do here is take 17. If we subtract 14.2, that'll give us 2 standard deviations. This symbol here is just called sigma. It's just a symbol for standard deviation. You can use any letter you want really, but this would be the standard symbol for standard deviation. So if you take the 17, the mean, subtract 14.2, that'll give you this data here, just up as far as here if you like, which is basically 2 standard deviations. So now all you got to do is work that out and solve for sigma. So if you take 17, subtract 14.2, you get 2.8 is equal to 2 standard deviations. So that means 1 standard deviation divided by 2 gives you 1.4. So the standard deviation is 1.4, and these are hours. H then would just be 17 plus 1 standard deviation plus another standard deviation. It's 2 standard deviations above 17. So that will give us H. So H is just going to be 19.8. So H is 19.8 hours. Okay, next one then. A random sample of 540 people was picked from all those who attended the music festival in 2025. They were asked if they had also attended the festival in 2024. Show that for this sample, the margin of error for a population proportion is 4.3%. So the margin of error if you like, is just going to be 1 over square root of n. So in our case, it's just 1 over 540 square rooted. When you do that, you get 0.043033 and so on, We want this to one decimal place, so that's 4.3%. This is a decimal here, and this is the percent here that they want to one decimal place. 350 of the 540 people had been at the festival in 2024. Work out the percentage of people in this sample who attended the festival in 2024. Give your answer correct to the nearest percent. So that's just a case of finding one number as a percentage of another number. The way you do that is you put it over it as a fraction, and then to change a fraction to a percentage you multiply by 100. When you do that you get 64.8148 and so on, and we want this to the nearest percent, which is 65%. Okay, in the past, before 2025, 67% of people who attended the festival in a given year also attended the festival the previous year. Use your answers to parts C1 and 2 to test the claim that this percentage has changed for the people who attended the festival in 2025 at a 5% level of significance. Show relevant calculations, state your conclusion, and give a reason for your conclusion. So again, I've done this out already just to save some time. It's effectively just an hypothesis test. So what you're going to do is just write down H0 and H1. H0 is what's being claimed. Well, what's being claimed is that the population proportion, which is just P, is equal to 67%. So 67% of people who attend a festival had attended the previous festival as well. H1 is that the population proportion is not 67%. So we've got to work out this confidence interval here first. So the way you do that is the population proportion is P, and it's somewhere between the P hat minus the margin of error and P hat plus the margin of error. P hat is the sample proportion. So we saw up here that they took a sample of 540, and out of that 540, 350 of them had been at a festival in 2024. So remember, this is 2025 at the moment, so a sample of 540 had been taken, 350 of them had been the year before. The P hat, the sample proportion, is 350 over 540, or just 65%. This is the P hat here. This is our margin of error here. So we've got to take 65%, subtract 4.3. We've got to take 65% and add 4.3. That gives us our confidence interval here between 60.7 and 69.6. So the 67% of people who attend the festival in a given year also attended the festival the previous year. This is what's being claimed. So when they took the sample this year in 2025, let's say in this case, we found that this is the confidence interval. The 67% does appear within this confidence interval. So we fail to reject. We're not going to reject the null hypothesis. This is still okay. The 67% still stands. So we fail to reject HO and conclude that there has been no change, and that 67% of people who attend a festival also attended the previous year. The reason for the conclusion is that 67% is within our confidence interval at a 5% level of significance. So that would be the end of that question. The organisers want to reduce the margin of error for the survey. Should they increase or decrease the number of people in the sample? Remember, the margin of error for the population proportion was 4.3%. So all you have to do there is just try some numbers. This was the margin of error that we calculated earlier, 4.3%. And we did that by doing 1 over the square root of the sample size, 540. So all I did was took a number bigger than 540 and picked a number less than 540. In this case, if I pick a number bigger, I got a smaller margin of error. I got 0.041, so that's 4.1%. That's less than 4.3%. So this seems to work. I also picked a bigger one. I picked 500, and you can see here that we get 4.5%, which is bigger than 4.3. They want to reduce the margin of error, so this is what they want. So if they want to reduce the margin of error, they have to increase the sample size. So that's what I have here. Okay, so that's it for question 9. Okay, so question 10. An ice cream cone has a radius of 2.8 centimeters. We have that here. Vertical height of 13.4 centimeters. That's here. The entire cone is filled with ice cream. There is also a hemisphere of the same radius of ice cream on the top of the cone. By finding the volume of cone and the volume of the hemisphere, work out the total volume of ice cream correct to the nearest cubic centimeter. So we need our tables there just to work out or to write down the volume of a cone. So the volume of a cone is 1/3 pi r squared h. We also need the volume of a hemisphere. Now the volume of a sphere is 4/3 pi r cubed. So what you really want to do is half that because we have a hemisphere. So we're multiplying by 1/2 if you like. That 2 will divide into that 4. So what you end up with is 2/3 pi r cubed. So we're going to use 2/3 pi r cubed. Now you can use 4/3 pi r cubed, work out your answer, and then half your answer at the end. That's perfectly fine as well. Okay, so let's put in the numbers here. The volume of the cone then is 1/3 times pi times the radius, which is 2.8. We've got to square that, and the height of the cone is 13.4. So we're going to work that out first. You'll get, we only need this to the nearest cubic centimeter, so I'm not going to do too many decimal places, but it's 110.0143, let's say. Let's work out the volume of the hemisphere. So that's 2/3 times pi times the radius, which is 2.8. We've got to cube that. So when you do that, you get 45.9761 and so on. So we want the volume of the whole thing. So the total volume is equal to those two things added there, which is 155.9905 and so on. We want this to the nearest centimeter cubed, so it's 156 centimeters cubed. That's the answer there. Okay, next question then. Some soft drink companies have changed the dimensions of their cylindrical cans. The table below shows the approximate dimensions of the old and new designs. So we can see here we've got the old can design, which is a cylinder, and the radius is 3.3, the height is 11.5. This is the new one here, and that has a smaller radius, so a smaller diameter, but we don't know the height. So for each design, we have the same volume. So in other words, the height must have increased then in order to keep the same volume if we reduce the radius. So anyway, we've got to work out h of the new can. So we are looking here really at the volume of a cylinder, which is pi r squared h. That's again in your tables. We know that the volume hasn't changed, so the volume is 393.4. Pi is pi. The radius, the new radius is 3, which we've got to square, and then we've got to multiply that by height. So we've got to just work out that height. So everything is multiplied on the right hand side. So what we can do is just divide. So we can take 393.4, divide by pi, and divide by 9. 3 squared there is just 9. And that'll leave h on its own. So that just gives us h then is equal to 13.913 and so on. We want this to one decimal place. So our answer is 13.9. It's a height, so we're looking at centimeters. And that's it for that part of the question. The total surface area of the new can design is 318.6 centimeters squared, correct to one decimal place. Work out the percentage increase in the total surface area from the old can design to the new can design. Give your answer as a percent correct to one decimal place. Okay, so this is kind of a long-winded question. We're going to look at the total surface area of the old can first. So the total surface area, if you think about a cylinder has two circles, one on the top, one on the bottom. So we need the area of those two circles anyway, this circle here and this one at the bottom as well. So the area of a circle is pi r squared. We have two of them, so I got to multiply by 2. Now there's also this curved surface area here that we've got to find the area of. Now that formula is as well in your tables. So that's just 2 pi or h. So this is what we're going to use in this question. So we're going to find the total surface area of the old can, the total surface area of the new can, and work from there. So let's look at the old one first. So we have 2 times pi times the radius for the old can was 3.3, which we got to square. We got 2 times pi 3 times the height, which was 11.5. So when you do that, you get 2442 over 25 pi. I'll just leave pi there for the moment. You can do it as a decimal, that's not a problem. You only have to give your answer to 1 decimal place, so don't round to 1 decimal place yet. You need maybe 3 or 4 decimal places if you're going to do that at this stage. You never round until the very end. Let's look at the total surface area of the new can then. Same formula, so we're just going to do 2 times pi times the new radius, which was 3, we've got to square, plus 2 times pi plus times 3 times that height, which was 13.9 there. So you can work that out as well on your calculator. You'll get 507 over 5 pi. So first of all, we've got to work out the increase. So the increase is just the new can, which is 507 over 5 pi, minus the old one, which is 2442 over 25 pi. So the increase in surface area when you do that is 93 over 25 pi. So that's the increase in the surface area. So that's going to be centimeters squared. Okay, so now we don't want the increase, we want the percentage increase. They don't give you enough room here to do this, but let's do it anyway. We want the percentage increase. So the way you do that is you take the increase, which is 93 over 25 pi. You put that over the original, the old surface area. So that's 2442 over 25 pi. So we're dividing those two, and then you want to multiply your answer by 100. So that's your percentage increase. A little bit messy there, but you can see we have a pi on the top, we have a pi on the bottom, so they'll divide. Now we have a fraction on the top, we have a fraction on the bottom. Now you can just do all of this on your calculator, it's not a problem. But if you look at it, you've got a fraction on the top, which is 93 over 25. You're dividing by a fraction. The way you divide by a fraction is you turn it upside down and multiply. So it's 2442. We're multiplying it all by 100 as well. You can see that 25 will cancel with the 25. So really all you've got to type into your calculator is 93 over 2442 as a fraction, and then multiply whatever that is by 100. When you do that, you will get 3.808 and so on. We want this to 1 decimal place, so it is just 3.8%. So there's a 3.8% increase in the surface area. Now I've kind of kept all the fractions together there. As I say, you can do that by converting those to decimals. Maybe you'll find that easier. That's not a problem. But the main thing to remember, if you do that, don't round to 1 decimal place until the very end. Keep a few decimal places the whole way down. Okay, next one then. The radius of the old can is 3.3 and the radius of the new can is 3 centimeters. The shop has a shelf of length 62 along here, 62 centimeters, and depth 32 centimeters. All cans are placed upright and are not stacked on top of each other. The cans are in rows where the first row is placed along the edge of the shelf and each other row is placed directly behind the first row. The entire base of each can must be in contact with the shelf. The diagram below shows some of the cans on the shelf. Work out how many more cans could be placed on this shelf if the new can design was used instead of the old can design. Okay, so when I read this first, I kind of misinterpreted it. I assumed that there were 12 cans here already, and we had to work out how many more cans you could actually fit on this shelf. What we need to do is look at the number of old cans that we can put on this shelf in total, the number of new cans we can put on this shelf in total, and see what the difference is. So let's work through that. So if we look at the shelf itself, it looks something like this. It's rectangular. This length here is 62 centimeters, and along here you got 32 centimeters. Now if we look at the old cans, first of all, the old can radius was 3.3. That means the diameter of the old can is 6.6 centimeters. That's really what we got to be looking at. So in other words, you've got a 6.6 centimeter can here, another 6.6 here, another 6.6 here, and so on all the way here, and also along this way as well. So you've got to put the cans in both directions. So we need to see how many 6.6s there are in 62. So we've got to take 62, divide by 6.6. That's the width of each can, or the diameter of each can. So when you do that, you'll get 9.4. That means we can fit 9 cans lengthways. We've got to take 32, we've got to divide that by 6.6, and we get 4.8. That means we can fit 4 cans along this way here. Now, it says in the question that you're not allowed any cans to kind of hang over the edge. The full base of each can must be in contact with the shelf. So that just means that we can fit 9 by 4 cans. So the number of cans that we can fit is just 9 times 4. So 4 9s, 36. Let's look at the new type can then. Well, the new type can has a diameter, has a radius of 3. So the diameter of the new can is 6 centimeters. So all I got to do is take 62 and divide by 6. So you take 62 and divide by 6, you get 10.3. So I can take 10 cans lengthways. We need to take 32 and divide by 6. That'll give you 5.3. So that means it'll take 5 cans this way. So in other words, we can take 10 times 5, which is equal to 50 cans, 50 of the new cans. This is the old cans here. So the difference then, the difference is just 50 minus 36, which is equal to 14 cans. So the new can design, you can fit an extra 14 cans. And that's it for that part of the question. In 2020, a soft drink had 35 grams of sugar in a 330 milliliter can. In 2021, the company made a new recipe with 30% less sugar. In 2025, the company reduced the sugar in the 2021 recipe by a further 20%. Work out how many grams of sugar there are in 500 milliliters in 2025. So give your answer correct to one decimal place. Okay, so initially we started in 2020 with 35 grams. So we've got to get, there are 2 ways of doing this. We want to get 30% of 35 grams and then subtract it. So that's kind of the longer way of doing it. But it's okay, you can do it that way. 30% of 35 grams. If you do that, you get 10.5 grams. So we want to reduce it by 30%. So we've got to take 35 grams and subtract 10.5 grams. That'll give you 24.5 grams. Now the easier way of doing that is the quicker way, rather, in one line rather than 2 lines. If you want to reduce 35 grams by 30%, you just multiply it by 0.7 and you should get 24.5 grams as well. This is kind of the quicker way of doing it, but either way is perfectly fine. Okay, so in 2025, the company reduced the sugar in the 2021 recipe by a further 20%. So in other words, we've got to take the 24.5 grams that we got here and reduce that by a further 20%. So I'll do it the longer way first anyway. So we take 20% of 24.5 grams, and when you do that you should get 4.9 grams. So we want to take 24.5 subtract 4.9 grams. So when you do that you will get 19.6 grams. And remember, this is it's in a 330 milliliter bottle. So by the way, the quicker way of doing these two lines here, you want to reduce something by 20%. So you multiply the 24.5 by 0.8 and you should also get 19.6 grams. So again, just a quicker way of doing that. Okay, so we have 19.6 grams in a 330 ml bottle. We have to work out how many grams there are in a 500 milliliter bottle. So what we're going to do is we want to find how many grams there are. So we're going to put grams on the right hand side. So we have 330 ml bottle, and that's equivalent to 19.6 grams. That's how many grams there are in 330 mils. So we want 1 mil, and then we want 500 mils. So how do you go from 330 down to 1? You divide by 330. So divide the right hand side by 330. So 330 divided by 330 will give you 1. So divide the right hand side by 330 as well. How do you go from 1 up to 500? You multiply by 500. So you take 19.6 over 330 multiplied by 500. So that's just simple calculator work at that stage. And what you should get is 29.6969 and so on. We want our answer to 1 decimal place, so that is just 29.7 grams. Okay, so that seems to be it for paper 2 and the Leaving Cert Ordinary Level paper for 2026.